The gain's all the way up. Let's just leave it at that. That's better than nothing. Whew. Okay. Now, we should be pointing at Terzon 7 here. Let's do a plate solve here. A-stop works well for me, but I have to make sure it has the correct focal length. Yes. Agreed. And A-stop has been working well for the last year. Yeah, we're about 1 degree off here, so that's why I would expect on the first major slew. So you can see how it's tuning up. Yeah, look at that. Finally over there to the right below me. Now you can make out that grainy picture of the scope in the dark. There's no moonlight tonight, so it is literally trying to image that scope in the exact darkness. Okay, now we should be looking now at Terzon 7. GGC 142, a globular cluster, and I don't see it. Do you guys? So let's reset this and let's manually type in here Terzon 7, and then let's just change this to 20 seconds and change this to 100. And then start live stacking. Now let's read something about Terzon 7, which is object 172. Finally, it literally took us an hour tonight to work out those bugs, and everything was working before we started, and then it just crashed. So Terzon 7 is a globular cluster, as actually we could have just, Stu told us that a long time ago, but it's a daunting test for the largest amateur scopes. Difficult for even deep sky diehards. Oh, it's not even in the Milky Way. So this globular is not part of the Milky Way. That's kind of what you were saying, isn't it, Stu, when you said it was part of the Sagittarius dwarf spheroidal galaxy. It's sometimes abbreviated SAG-DEG. 65,000 light years away, making it the second closest satellite of the Milky Way. Okay, so let's pull off this and do a color. This is a pretty busy field of view, isn't it? So what would this glob look like if it were to be in our frame? Maybe that? Let's back off again and use deep sky image annotation. So it does not have Terzon 7 in its catalog. Is this, that's probably the object. Let's put our crosshairs on. Right there is where it should be. So could it be like this? That zoomed in at 125%. What do you guys think? Yeah, in the drawing that Phil Harrington gives us, see how in this field of view, there are these two stars up here and a star here, and the glob kind of completes the rectangle. So let's look for that. So here are these two stars, which up is to our right. Here's the corner, and this glob completes the rectangle. So that is the smallest glob that we've ever observed, bar none. It's so small that it's not even listed in the Deep Sky Image Annotation database. But right there it is. Hubble has a beautiful picture of this. So we're at 100, oh no, we're not. We're at 100 right there. That's 100. Boy, it's no wonder that Messier didn't find this. It would not have leaped off the page, would it? In fact, did we read that this thing was located in 1968? Is that what we saw? Yeah. This was discovered in 1968. All right, so let's make an observation of this and say, let's check and make sure we're still on 915, and we are. This is the smallest glob we've ever observed. We located it thanks to Harrington's star chart. Not a lot to see there. So let's go out to the Hubble view right here and say Hubble Tarzan 7. Wow. We see what you mean, Stu. That is striking, isn't it? So obviously this is a very small field of view, but it is letting you catch this entire glob. And for the Hubble to catch an entire globular cluster shows you just how small it is. It's a beautiful image, all right. And that's right here. 65,000 light years, Stu said. Not a part of the Milky Way, which is rare, isn't it, for globs. Crank up the gain to see it. I guess we could, but we're stacking, so I don't know that the gain will make too much difference, will it, while we're stacking? Let's try. Ray, I noticed you're always wanting us to crank up the gain. You are a big believer in gain. Now see, I think it just kind of, let's color match again. And let's see if we can play with these mids. There's a lot of mottling, a lot of noise in this field of view, huh? A lot of mottled frame. I think that's all we're going to make out, is just that collection of, this collection of stars right here. It's kind of an arc. Not particularly beautiful, but we have to remember it's low on the horizon right now. I'm going to add that to our, let's see. was tiny and low on the horizon. And, you know, it's dim. All right, let's hit our next object and see if we can get some rhythm going here. For our next object, let's go to NGC 6578. NGC 6578. It's a planetary nebula. This one's at 23.5 degrees currently. NGC 6578, a planetary nebula. And is that Sagittarius? SGR. What is SGR? Yes. Just right off the top of the tea kettle. If you ever are looking in that low southern sky, you've probably seen this handle of this teapot. And here's the spout. And there's the lid. And right off the top is this object. NGC 6578. .18 degree correction here, so that's good. We're in the right ballpark. This is a nice star field. Ray says he typically sets the gain at 250 to 350, depending on the scope you're using. But is that at 20 seconds, Ray? 20-second exposures. NGC 6578 is a planetary nebula located in Sagittarius. It has a 16th magnitude central star. Wow. Okay, so let's go up here to look at that. You can see that all that background cloud material. See, look. See how there's just a background cloud material in this entire section. It's because we're on the stripe of the Milky Way. And look how our scope is picking up on that, just even in the first couple of frames. Now, would this be the planetary right there? Or is it here? Let's see if this is in the deep sky image annotation. NG6065. I think we ought to plate solve only and get that receipt. I think it's this orangish object right there. Look how bright orange it is. Boy, our focus has slipped, hasn't it? What a nice field of stars, though. Look at all the different colors. Low in the sky, yeah, you're right. It's 23 degrees. But you know, for some reason with this rig, we can image pretty much at 10 degrees all the way around the sky. by God's grace. So now let's put the deep sky image annotation back on. Yeah, there it is. See how accurately now the deep sky image annotation has traced it. Wow, so it was not the orange one. It was adjacent to the orange one. So we can see the planetary nebula, but we're not going to see the central star, I don't think, with this focus anyway. It just pretty much looks like another star. That's how small it is. This is object 140 in the Deep Sky Challenge list. It's definitely listed under a large scope challenge. It says it's one of the richest regions of the night sky. It's at the top of the Teapot asterism. Tells you where to find it. It's easy enough to locate, not easy to see. And there's a 11th magnitude star just 20 arc seconds to the west. Right. That would be this one. And of course these are close as well. Try your highest magnification. A round mottled disk. Well, basically everything is mottled for us at 286% of our optical zoom here. So that's at 100%. And I would say that's still got just a little bit of fuzziness in it, doesn't it, for our focus. So I'll tell you what let's do. Let's stop this live stacking and let's go to some place like someplace where there's not a big star field, you know, not a lot of Milky Way clouds. Just something random like here. Something like that. Let's turn off deep sky image annotation. And then let's just go right. Doesn't matter, someplace like with several stars, but no, that's still got some background nebulosity, doesn't it? Let's get away from that nebulosity. Just find a nice pattern where there are several stars. How about right there? And let's go to that. Let's look at our scope cam. Yeah, see there you can see the scope turning. It had to go around the long way. Boy, that helps so much to have a camera on the scope, doesn't it? I mean, without it, you just really are operating in the blind. There comes the RASA on the screen now. See it sneaking down there like a satellite. Okay, so now it's pretty well settled. Now, let's close the camera here and open up Nina. There was enough temperature shift that that field of stars is getting a little bit ugly. And then let's go here to imaging. And let's do a quick focus run. Okay, so Azray says, low in the sky. No, with the RASA, I keep it around 5 to 10 seconds. Yeah. I really like this 20-second view, but I don't mind. It's obvious what you're doing, Ray. You're using a faster shutter speed, you know, and then a higher gain. And I'm using stacked images of a longer shutter speed and a lower gain because I really like that dynamic range of the 2600 at the 100 gain mark. It gives you the most f-stops, the most dynamic range. And I just think that's more beautiful. So it's just different opinions. I know different people run their rigs differently. I just love that standard 20-second time exposure, 100 gain stack. And you're doing the shorter exposures with the higher gain. And I just think for my camera, this gives a really pleasant dynamic range. So you like that star field, huh, Tiffany? You know, Vito, you're nice to encourage. It's really the observatory that does the trick. That's the thing. And then that pier, so that we can get that scope up above the edge of the observatory. And that's why we can get that 10 degrees in all parts of the sky, because we have that adjustable height pier pushing the scope up above the top. And so we're thankful for the folks at Pier-Tech for making that. Tiffany says, you did a great job, Vito. That's awesome, Tiffany. So what are we doing now? I think if you've been around the channel for a while, you know what's going on here. Nina is a different piece of software with a very nice plugin that's called, what's it called? Something like Joko, whatever. I don't know if I can turn off of it while we're imaging or not and go look at the plugin name. Let's see if we can. Hocus Focus by Joko Geo, George Helios, Joko Geo, Hocus Focus. That's the plugin name. And what Hocus Focus does is it takes whatever point you are and it takes a picture and then it moves the focus motor off in a direction that it picks. Maybe it moves it out first, let's say. So our focus started right here and it moved it out. And then it takes another picture of that. And it compares which picture had the sharper stars. And then it moves it another segment out. So the focus motor is actually moving the mirror out away from the corrector plate at the end of the scope, so that the distance between the mirror and the corrector plate is longer, for instance. And it keeps doing that, a little segment at a time. And it keeps doing that until it can tell that you've bottomed out and the stars are now pretty much getting the same sharpness each time. And how does this program measure star sharpness? It uses a thing called half density something radius. It's basically measuring how wide the point is. That's what it's basically doing. And in simplified terms, how wide is the point of the star? How many pixels does it take up? And it tries to find the setting of the focus motor so that it takes up the smallest amount of pixels, and it does that until it can tell a trend. And you can see here, it went 4 stops, 4 positions before it said, okay, this is going the wrong direction. So now we know this was the best focus. So what does this tell us about how far out of focus we were? We were here, and we needed to be here. So several stops on our focus motor in order to get our focus right. So now we'll go back and disconnect the focuser, disconnect the camera. So you're saying, well, why couldn't we just have done this in SharpCap? Well, we could have in SharpCap, but to me, no offense to SharpCap, but I just don't think the routine in SharpCap is as well developed yet as the Hocus Focus plugin is in Nina. There is a focus assistant in SharpCap, but I haven't been able to get it to work as well yet as that plugin. And keep in mind, we're running this RASA 11, which has a very narrow range of focus. I just studied this again this past week. Happened to be listening and saying, oh, look at that pinpoint focus now. That is beautiful. So now if we were to go back to, let's see, we're ready to slew here, aren't we? Yeah. If we were to go back to NGC 6578 again, that star field will look completely different now than what it looked like before. Remember, we have to travel all the way around the horn because the scope can't travel past the meridian. It has to, if the scope is here, it has to go all the way around the meridian. So that's the movement that you're seeing there. Hocus Focus. Yeah, Ray was trying to help me remember that plugin. Ricky helped me remember full width half maximum. Or Ranjit says maybe it's the half flux diameter. I think it is the half flux diameter that we're using. Stu says he still just twiddles the knobs. Actually, that's a little simpler, isn't it, Stu? Okay, so where were we? We were at the Sagittarius star cloud, which is right here. So there's the RASA. It's already there. So let's see, show the chart so it synchronizes with that position. Now let's go back to and let's plate solve here again. In GC 6578, meanwhile, is at 23 degrees now. And there will be a correction here because we did travel quite a lot of the sky. Oh, not that much, 0.05 of a degree. So it actually remembered pretty well its model. That's a good sign. We're going to put in NGC 6578 one more time here. And let's do 8 seconds at, what did you say, Ray? 250 to 300, is that what you said you did? 250 gain. And live stack that. Clear the first image just to clear what was in there for the memory before. So anyway, that entire process of that focus is all automatic. And what I like for a RASA is it leaves no room for error in the human intervention. And when your critical focus zone is literally the width of a human hair, I think that that Hocus Pocus plugin is clutch. So that's 100%. You know, some of this is just atmospheric disturbance, but we did improve our focus some. But remember, this is our planetary nebula here, and there's so much atmosphere that we're looking through. I don't know if we're going to see that central star. Boy, those frames accumulate a lot faster, don't they, Ray, when you're at 8 seconds. Vito says, this content is amazing, can't be found anywhere else live. You are so nice. Keep in mind that it took us a while to get started though, Vito, but that's very kind of you to say. So here's NGC 6578 at 250% of our optical zoom. So we're using a lot of digital zoom. So it's that object right there. It's a very small planetary. Let's go ahead and add an observation now and say, so tiny. How many arc seconds do you suppose this is in width? 9. 9 arc seconds wide. Just a dot. It's a dot. No central star visible at this altitude. Maybe if we came back to this in another time of the year, when this object was higher in the sky, we might get that central star, but we're not getting it here. Just looks like a fuzzy star at this point. All right, let's go to IC4732. IC4732. Right there it is. Still in the general area of the Sagittarius star cloud. That's this incredible giant nebula here, bigger than the frame of our RASA. IC4732. Boy, look at this star field. Is that not beautiful? Let's go look at it live. So we'll do, we don't need to plate solve. Oh look, that's it. That's the planetary we're looking for right there. Let's live stack this a little bit. Let me go back to my favorite 20 seconds at gain of 100. And live stack. Oh, thank you so much, books. You guys are so nice to, yeah, Sarah Mon was saying, hey. Okay, we're going to clear this. Thank you guys so much for letting me know. Okay, this is IC4732. Stu, what can you tell us about IC4732? Quantum space, nothing better than finishing the shift and enjoying these beautiful things that life offers you. You are right, quantum space. Where are you observing from, quantum space? I don't remember. Let's do plate solve only here. Maybe it's this. Let's do a color balance. Bring our blacks over to here. And then bump our mids up a little. Now let's do deep sky image annotation. Right there is IC4732. Again, it's very tiny. I would have chosen the wrong one. How about you guys? Oh, it's got that green oxygen hue. No central star. That's 633% digital zoom. So this thing, we can literally count how many pixels wide it is. It's really just 1, 2, 3, 4, 5, 6 pixels wide. So that's 100% of our optical zoom. This is object 141. I'm eager to see what they say about this. Whenever I'm asked to name my favorite globular cluster, M22 in Sagittarius is always high on my list. I find it more impressive than M13. And then he says, IC4732 lies just 1.4 degrees north-northwest of M22. It's a tiny disk. It's difficult to pick out from a mob of field stars. Difficult, but not impossible. And then it tells you how to find it. He says, it'll not show up as much more than a point of faintly bluish light. We obviously need to color balance more if that's supposed to be blue, because to my eyes that looks really green. Right there, but I am colorblind. Let's zoom in digitally. Does that look blue to you guys? It looks green to me. He says, even the professionals can't resolve its disk beyond a small sphere. And while few amateurs have ever spotted IC4732, even fewer can claim to have glimpsed its central star, glowing at a dismal magnitude of 16.6. Rats! Now I wish we could see it. Now it is at just 23 degrees, but now I really wish we could see the central star. We're just at 3 minutes, so let's let it accumulate a little bit more. Thank you for these live streams. Much appreciated. You're very kind, Ranjit, to say that. Stu, the immense distance IC4732, about 16,000 light years, makes it extremely faint in the skies of Earth. The nebula itself is only 12th magnitude, and its central star, HD 171131, has a remarkably faint visual magnitude of +20. Quantum space is in Miami. Azray says, must be tiny. Pier-Tech says, it's emerald! I am glad to hear you say that. This is going to be the official planetary nebula of Emerald Hill skies. Stu, the entire nebula has an apparent diameter of just, oh my goodness. Are you fibbing, Stu? Is this less than 1 arc-second wide, suggesting, given its distance, that in reality it is a little less than 1 light year across? Quantum space says, oh, maybe between the blue to green range. So your color vision's better than mine. Let's see if we can dial this up a little bit. Let's not make our background quite so black. We're at 240% of our optical zoom. Now let's dial up our mids and let's zoom in that way. That's not going to show us a central star, is it? Okay, let's do this a different way. Let's back off our mids. Boy, I think we need a longer focal length telescope. Oh, I don't know, gang. Look at that. See how the pixel in the middle? It's literally just 1 pixel wide. But look, when we backed off our mids, boy, it's dim. It is dim, but you know what? I would say that that middle pixel is brighter than its surrounding pixels. And that's after 6 minutes of integration. This tiny object is 16,000 light years distant and extremely faint, just 12th magnitude. Its central star, according to Stu, is HD 171131 and just +20 magnitude. 0.7 arc seconds wide. The entire object is just 1 light year wide. Ray says, I'll have to break out the 16-inch Dob for that one. Sure enough, IC4732 falls between the solar system and the nucleus of the Milky Way. It appears to lie approximately halfway between those 2 points. Wow, that's cool. Well, I'm going to say if we use our imaginations just a tad, we think we can see that the central pixel is brighter than the surrounding pixels. We're going to count that as having seen the central star. Harrington says, few amateurs have even observed the planetary, and even fewer the central star. Fun stuff. Need more power, Scotty. I'm giving her all she's got, Captain. The photons from that star are struggling to reach the camera sensor. That's right. Stu says, if it's only 1 light year across, how old is it? That's a great question. Can't find when it was discovered. Yeah, nothing here in Harrington's book either. You can see why he calls this book Cosmic Challenges, Cosmic Challenge, because he's basically trying to give you the hard stuff. He says, this one's difficult. And keep in mind, we are at Bortle 6 in the suburbs of a city of 1.5 million people. Well, that's 10 minutes. I think we're going to call it, but I'm thinking that central star is, the pixel is brighter. Like right there, see? I'm going to say that central pixel is brighter. That is 100%. So remember where the planetary is. And now let's go out to the full frame. Wow. It's crazy, isn't it? It's no wonder few have taken time to observe it. Okay. Here's Barnard 86. Let's go there. So we're going to go to the next target, Barnard 86. Oh, you found Phil Harrington's book in Twaranga. That's awesome, Stu. Yeah, I wish we should have gone to other planetary. You're right. I saw that. Well, now, Stu, I don't even have to read the book. If you're reading it for us, you can tell us what we need to know. Whew, I feel so much less stressed now. Are we going to be able to see Barnard 86? This is object 101. Object 101. Stu, how do you tell if you're a faithful participant? Yeah, we missed those, Stu. We should have gone to those. Okay, so Barnard 86. Are we going to be able to see this? 5 arc minutes. Sure we are. Boy. There we go. This was what? 1919, you think, or 1927? Harrington says many amateurs tend to shy away from seeking out dark nebulae. He says, in a way, that makes sense. If you're in a light-polluted sky, so it falls victim to less than perfect sky conditions. The slightest haze is usually enough to keep you from seeing it. Okay, so first, let's do our display histogram. Then let's do the big histogram. Oh my goodness, there we go. First frame. With EAA, you can see this dark nebula in the first frame. And Harrington's just now talking about how many people shy away from it. EAA rocks. Look, right there it is. It's beautiful. And you kind of have to have a love for things that are dark, don't you? So again, you guys that have been on the channel before, you know, the regulars, the usual suspects, as somebody called us one night. That might have been Stu. The usual suspects know that dark nebulae are just clouds that are so thick that they're keeping the background stars from shining through. Look at this. This looks like almost a distant globular. Do you think that is? Anybody? It is. It's NGC 6520. Okay, so let's do this observation here. We could see this dark nebula after the first frame of just 20 seconds. We could easily make out NGC 6520. I trust that that's a globular, right? The globular next door. Barnard was onto something when he cataloged all these. A molecular cloud dark absorption nebula. BOK globule. A Bok globule. I've heard that term before. A Bok globule. I don't think I've ever typed it. Towards the southern constellation Ophiuchus and well within the Milky Way galaxy, a distance of 407 light years distant. Stu says, ooh, Bok globule, awesome. The cloud's mass is about twice that of the sun. Wow, that's not that big, really. The cloud's mass is twice that of the sun. Measures half a light year across. Quantum Space says, just need 20 seconds and I fall in love with this nebula. That's the way I felt too, Quantum Space. Yeah, it is striking. Oh my goodness. JM, thanks for the $5 super chat. Late to the viewing party and we'll have to catch the replay, but thank you, Doug, at Emerald Hill Skies for facilitating these sessions. JM, I already told the gang that anything like this that's given tonight, we're going to give to those victims of the flood in the east part of Libya, where 11,000 people were killed instantly by those two dams bursting and wiping away the center of that city into the sea. Another 10,000 missing. So your super chat gift, we're going to give directly to them, and that'll go into work instantly. There's no delay in helping them. So thank you very much. Bulk said he looked at Coroni Australis the other night, a beautiful set of reflection and dark nebulae around a couple of bright double stars in our southern skies. Yeah, that's awesome that you're seeing that, Books. All right, let's just kind of back off here now. And all of this cloud, let's go look at this real quick in the, oh, I already closed the observation, and when I do that, I've got the filter set so that it's Barnard 68, so we'll have to go find this manually. Why is my Control S not working? Let me use the F3, see if that works. There we go. Barnard 68 or 86. Oh, he doesn't have it. I wonder if that's LDN 93. Maybe it's known as that name as well. Ink Spot Nebula. Yeah, B86. So it's just abbreviated B86 in star charts, like Stellarium. That glob, or whatever cluster that is called Dead Man's Chest Cluster. It's an open cluster. Let's go back and look at that again. Okay, I can see that, yeah, an open cluster. Anyway, look in Stellarium how striking it is. It's just, now at that range it's not so much, but here it's represented well in Stellarium. Yeah, it's beautiful. Let's do a picture of this. It's really cool. That's just 17 degrees above the horizon, so not an ideal place. Oh my goodness, folks, thanks so much for that encouragement. We will help the victims of that flood now. Thank you so much, folks. Rats, we're just 2 minutes left. Guys, I just want to say I apologize for the opening. I don't know whether to maybe edit out that opening and start with just this last hour, so only you guys who are live will know the pain of watching that first hour. So what do we think caused that? I don't know. I was thinking, when you get an observatory, you kind of feel like you should be able to walk in and just turn things on and go. But I think when there are a couple of weeks between observing sessions, maybe there can be gremlins sneak in, but you know, when I used to set things up from scratch every time, oh my goodness, it was horrible like this every time. But with the observatory, I would say, boy, I've never actually statistically kept track, but I want to say 90% of the time, it's just like you turn things on and it works. 10% of the time, there's a little glitch, and I apologize for that tonight. So I might, what do you guys, we'll let you guys vote. Should we edit out that first hour and make the recording just the hour when we actually could do production, maybe? Stu says, because of the opacity, its interior is extremely cold, its temperature being about 16 Kelvin. Wow, 16 Kelvin, Stu translates for us, is minus 431 degrees Fahrenheit, or minus 257 centigrade. That is cold, dark space. So you guys can vote. Do you think we ought to trim the front end off so that our recorded listeners won't know the pain of that first hour getting oriented? And it'll just be a 1 hour observing session that way. That's what I think we ought to do. But you guys can vote. Tell us what you think. Oh my goodness, JM just gave another $5. So Boakes gave 10 and JM just gave another 5 after having already done 5. I know what he did. He wanted to match Boakes. That's what it was. It was the competitive element. You guys are great. Thanks so much for the encouragement. Okay, so Stu says, yeah, let's trim it off. Okay, so that's what we'll do. We will trim off the front end. Rajit says, hey, no issues. It's all part of live broadcasting. Keep it up as is. Well, thank you, Rajit. I kind of want to have mercy on those who stop by the recording And next time, maybe we'll make sure that we actually do some observing first. I mean, everything was working, but we had not actually moved the scope yet. So that's another thing we can do for you guys. All right, we'll call it there. If you like content like this, especially the last hour of it, if you haven't subscribed before and you're watching this live or else recorded and you would like to subscribe, by all means, if that's what you want to do, please subscribe. If you like it and you want to do thumbs up, they tell us that increases the chances that somebody will find it. So hit that like button. And by all means, thanks for being a part of this. We look at this as team astronomy. Astronomy is no longer a kind of a solo deal. It's now a team sport. And Stu says, edit out Stu's singing. Okay, we'll work on that, Stu. You're a riot. And we'll look for the next clear night. We try to do one night a week. Some nights there isn't a clear night in the whole week long. And some nights that means that we'll have to go 2 weeks. But we'll try our best to be back once a week on a clear night. God bless you guys for hanging in there with us throughout that first hour that was rough getting going. That's electronically assisted astronomy, especially streaming it. Thanks, take care, have a good evening, and thanks to God for making these cool objects that we can go observe, and He's the guy who makes this stuff, and we're able just to see His handiwork. So God bless, have a great evening, and we'll see you next time. Take care. Thanks to our live observers especially.